everybody. Hope lunch was fine. I just had breakfast. Sorry. I will wish I will be there, but well, I need to be here by these days. So we are going to be talking about remaking a Jupyter kernel for Crystal. Well, you probably know me as Cardiff in GitHub. I hope you still remember me from Crystal contribution. I try to still be on the project. But well, besides working on everything, I'm a Crystal core team member. So on the agenda for this talk is to talk about a little bit of the motivations behind this work. I will do a quick demo. And then I hope to discuss some challenges and steps going forward for this endeavor or ideas. So we will be focusing on playground environments. As an analogy in the real world, playground is it's a place where you can explore and learn. The fact that I have a 2-year-old daughter maybe is affecting my my perspective on some of these things. There are various playground environments. Some are depending on languages, some are more flexible. These are a couple of the one I know a little bit more or less, depending on each of those. But for example, you hopefully know the Crystal Play, the one that is integrated in the compiler. It boot the HTTP server, and you can start coding right away in Crystal. For me, it feels lightweight because you don't need to create a file before starting to code. You don't need to set up the editor. And it gives you visibility of intermediate values and types. So you start learning a little bit more what are the semantics of Crystal. Without additional tooling, without anything else, like the value is trying you to discover how that works. There are other there are other features I'm really proud of, though, like supporting literate files where you have Markdown and you can have mixed Markdown and Crystal code, and you can execute those, and allowing presentations from those same Markdown using Reveal.js. But I don't believe those are widely used. But it was fun to have those at the beginning. Then we have Jupyter Notebook, which are the ones that we are going to be using today. Here, instead of having one single code editor, you will have cells or snippets where you input the pieces of code, and you evaluate those one after the other, and the whole context of the evaluation is kind of suspended. It's there, it's live, more like in a REPL environment where you input a couple of lines at a time, and you have this environment live for you to keep doing things with those values. It supports rich output, like outputting not only text, but HTML, SVG, images. It supports interactive controls like sliders, so you can build things that are a little bit more interactive and UI, with more UI. And it's good because it's a very iterative process of developing within this. And again, there is no need to create a file, although you usually store those notebooks in a file. The Jupyter, when you are executing a Jupyter notebook, you can't assume that there is a file or even a directory as context, which kind of change some of the rules of the game. We will see that later. Then Swift playgrounds are really fancy. It has really fancy controls, and it's like it's very top-notch in the visuals. But well, it's very tied to Swift. And then Observable HQ, it's another example I really like a lot. It has this concept of cells as in Jupyter Notebook, but the semantics is very different. There are like reactive cells, and there is no need to have a linear dependency between those. And although it works on JavaScript, it gives another semantic. So well, it's like a different paradigm, even if it's the same language. So I think there are lessons to be learned from different from these playground environments. Because they serve how to explore the language or to learn what you can do, or start playing with some packages and then maybe throwing away or evolving the code from there. Another motivation, a little bit more biased toward Crystal, is we have now the interpreter, or it is in progress, right? And we want to present it to broader audience, to broader users, because this will give us more feedback, and it will give us input to what needs to be improved. So that is like, hey, if we use more the interpreter more, then well, we will catch more bugs because we will have more feedback. That's essentially the feedback loop that we are looking at. The things are going to be presented lives in this repo, the Cardiff /iCrystal. It is forked from this other repo that, like a big shout out. Without that repo, I wouldn't have started with this, because I was like, oh, I don't know how to start with this Jupyter notebook protocol that I need to implement. But having this as a start was really, really great. So I have a Jupyter server running already. And I need to go out from subscript here. So on Jupyter, I have a couple of examples. I will open the first one, and this is this is Crystal. The font is fine. I could increase it a little bit more, just probably. Yeah. So I can evaluate one cell, evaluate the other, keep changing and evaluating, and this is working this out with the repo. I can use this directly. There are a couple of UIs alternatives. One of the alternatives is actually using VS Code. Like I can, again, this is the same example. I will increase the font once more. Yeah, there, better. Again, the same example. Let me connect to the server that is evaluating, and yeah, it is working, and the response times are fine, are good. We have rich output support, so I need to connect to each lesson. So here I'm returning the HTML. I can return JSON. It doesn't look much, but it has colors, and on the other UI you can open per keys, and we can output SVG. We have a circle, great. Let me select the kernel here. This is a longer example. It has some of the boilerplate because it doesn't hide it behind like a standard library yet for the notebook. But essentially, we have a component that has it is a counter with a name. This is some boilerplate to know how to display the counter, but essentially we have a render method that outputs HTML using insert interpolation in the lack of something better. And we have an int method that will update the counter. So we evaluate this definition, we create a counter, we can display it, we can increase the number, and we can say to update the display that it was present on the previous cell. So there is already some interactivity there. So when evaluating a cell, you can change the state of another one if you implement this display, update display protocol. And you can even do this in a loop with sleep timers, and you will see that this starts and no hands, yay. So that is updating all the way. Another good example of things that we can do today. I mentioned that it is not certain that you can assume that there is a file. So the current directory of evaluation of this is some random current temporal directory. And we have shard integrations. We can install any shard directly. This is different, right? For using shard, we are used to having a file and we run shard update. So this is making some of that behind the scenes, but since we don't have a directory necessarily, we can't have that shard installed. Even the files can be in a different location than the server. It's a different environment. So we are installing a shard, a very ugly shard that only knows how to do lorem ipsum. So, but that is coming. But if we can have a more real example, using these two shards, one that outputs PNG and one that generates QR that works together. So here we are installing it. We know exactly which versions were there because that's the output of shards, the shards command. We are creating some buffer there. We are initializing a little bit with some random colors there. We have some I/O in memory. We are writing the DNG there. We can encode it in base 64, but actually we can even display it since it's base 64. There is no need to generate files, so it's colorful. And we have some way to generate QRs, codes as SVG, or as before, as base 64 encoded, as PNG encoded in base 64. So this is working. The response times are pretty good, especially if you compile the kernel, some of the kernel parts in release mode, because it's actually using the compiler. Fun fact, I developed all this with the compiler in debug mode, and I was satisfied with the performance. So, and then I switched to release mode and say, this is even better. So great. Now I need to go back to the presentation. So the demo. This is what we have. We have this kernel powered by interpreter. It supports rich output, supports the display and update display protocol of Jupyter Notebook, and it supports shards integration. Part of this project motivated the creation of the Crystal REPL server, which is a different repository, which wraps the interpreter or the REPL in an HTTP with an HTTP API that can be accessed through sockets. So that is the one that is essentially a Crystal compiler itself with some other API. So that was the demo. Let's move on and discuss some of the challenges. I want to focus on 3 aspects. There might be more to discover, but I want to focus on error reporting, API design of the standard library, and migration of the code, how you can move the code from the notebook to real code, right, in files. But all of these challenges comes because you are coding Crystal in a different context. Like, it's not that, yeah, throw the interpreter, it will be fine. It's not as simple. It is a different context and change things in various ways. We saw one with shards, like, hey, this how is it that I can install shards in this like script fashion? Like that's not how shard work, but it's how shards is needed to work for this environment. So that is already a change due to the change of context. But well, going back to error reporting, we have this code which will not compile. Like this is the whole program calling a wrong method and an existing method. The compiler will point us, hey, this method with this little arrow is wrong. Like it is not defined, and that is very clear. We have the line numbers, the column number is great. In the current interpreter or in the current REPL, we have more or less the same experience, but we don't, like, as long as the snippet is small enough, this error message is clear enough. If we'll have like 2 occurrences and one is fine and the other is not, then it will not be that clear. So it's not the same quality or the same clarity as the one before. In the current kernel, since it is using the REPL, what we have is something very similar. We're not showing the line number. Again, if the snippet is small enough, it should be enough. But we already know that there might be some gaps that might not be clear. In the Crystal Playground, we have this. Maybe if you don't if you don't write invalid Crystal programs, you won't see this. But we have this kind of errors there that points exactly where, I would say, even nicer than the compiler in the CLI because you point exactly to that location. But well, it's because we can do that because the code is right there, although there is no file. When we're reporting like far, not the far part, slightly far errors, again, the same problem, an existing method, but it's now called in some method. The compiler will tell us, hey, this is where something goes wrong, or we can even request deeper trace, so you can have all the tracing because bar1 called this, and then you have this method. This experience is great, and it gives you all the information that you need. On the current interpreter, again, this will be the session. First on the left, we declare the method, and then we try to evaluate, and we get kind of the same error as before, but line numbers doesn't make a lot of sense here. Like we have, like the REPL says 1, 2, 3, 4, but the error says 1, 2, and the number 1 is actually the line 1 of the second snippet. So there's mixed signals here. Like where's the error? So there is already something to improve here in the REPL. In the current kernel, well, it's just, yeah, bar doesn't work, bar within doesn't work, and good luck. Definitely we couldn't, I could have added more information, but I think this was added in the previous full trace was added in 110, so I didn't have time to update. Before it was only showing the top level. So there are things that are already improving. In the Crystal Play, we have this. So it is, again, a little bit more clear, hopefully. I wish they will have like little arrows pointing, first read this, then read that, as Xcode does. But well, these are error reports. Moving to API designs, challenges. If we were implementing an HTTP server on the REPL, I will expect something like this. This is an hypothetical situation, like where I first create a server, then I bind the port, I start the server right away, and then I like keep adding or replacing the handlers. That will give us an interactive way of not restarting the server, exploring how it works. But this is not the API that we have today in the standard library, and it's not the one that was needed until today. Like first we create a server, we declare the handlers, and then we put the listen in the very end because that hangs the process, and that's why I need to do spawn here because I don't want to block the whole evaluation. So there is some tension, like what is the best API for the kernel might not be the best API for the classic file context. And I'm not sure we need to cover all the cases because it's different. Although it's the same language in a different context, there might be different needs. And then just shortly regarding code migration, like since it's a different context, then you will start having some specifics of Jupyter regards of the semantic. Like I have some, like the counter, or I could have some progress data type, and I wanted that to be displayed. But then when I want to copy and paste that code as directly as possible, well, I need to remove all the Jupyter stuff. So I would rather have some of those implicit. So instead of calling to display, and say, this is a progress. The progress is like know how to display itself. And for that, we need some kind of introspection. For this, essentially, it's like after you are evaluating an expression in the REPL, in the next session, I would like to be able to say, hey, last expression, like in the IRB, it's underscore. Underscore is always the last expression. I think we don't have that yet on our REPL. So accessing the last value that was evaluated will be great to allow this, because then we can do some runtime introspection of the values. So going forward, I want to discuss some specific ideas for Crystal, for this kernel itself, and some developer experience in general that could be applied to this kernel. All good, Beta? I heard. Okay. We already see that would be good to have some better error reporting, more structured information for the REPL, and access last value. The Crystal REPL server itself, now it is decoupled from the compiler. I believe that integrating that in the compiler as an additional tool will be valuable because it will be easier to ship it, because we don't need to build a compiler and ship it externally in every project. But before doing that, either we need to battle test it a little bit because it's very early stages, or at least we need to see if it can boost some other tooling. Like Maya developed this tool that evaluates Crystal code in comments. So I believe that we can do some LSP kind of tooling on top of this, because it is exposing the REPL in a more library fashion. And then something that internally in the Crystal, the REPL and interpreter are very tight. So actually, when you are developing the interpreter, you get the debugger support, and you get how to input things from the CLI that it doesn't need to be there if you are just using the interpreter. So I don't know. They are very tight, because the interpreter was built for the REPL, mostly for debugging purposes, and that's why some of these stories doesn't. They are reporting, and last value maybe didn't make sense initially, but now this is pushing for more. Then in the Jupyter kernel itself, I don't know Python basically, and I have very little knowledge of the Jupyter ecosystem at all. But I know we don't support standard input, but we could. We don't support widgets, we could. The kernel architecture is a bit more in a proof of concept state, and there is a project called Zeus on Jupyter, which is a C++ implementation scaffolding of a kernel. Now that we have Crystal REPL server, actually the whole kernel doesn't need to be in Crystal. It is less fun for us if it's not in Crystal, but maybe implementing the kernel using Zeus will give us widgets and a couple of other features right away, and we still use the REPL server for evaluating. And something that is definitely needed are, if we are going this direction for tooling, is guides. Because now instead of, oh, I want to use Crystal, let's use Jupyter, and now I need to install Python, and it's less clear how to do that for newcomers if we want this environment for learning and explorations. And then finally, some more broad ideas is since the context where we are evaluating code is different, there are some things that might be easier to be done, or they are tempting to be done. One is, for example, autocomplete. Since we are editing one cell at a time and we have context, it might be easier to get the autocomplete for this piece of code, because you are focused on a cell, you are unlikely to be inside a method or inside a loop. And even if you only support autocomplete for top level lines, it's worth it in this environment. Maybe it wasn't worth it when you are coding in files, but in this environment, it's maybe easier and worth it. Same as covering in documentation, Jupyter has this support if you implement in the kernel. But something it's not clear to me how to do is to do some bug detection and reporting. The current playground, the Crystal Play, for it to work, when you feed them code, it instrumented to have these values displayed on the side, right? That instrumentation can fail, but there is a mechanism to detecting if the instrumentation failed. And if so, the user is prompted with, hey, you found a bug, please send us this code. That's the older thing that we need, and that help us to iterate very fast in the playground and solve all those issues. So I know it's not clear where or how to do that in this environment, because there are multiple pieces: the kernel, Jupyter, the REPL. So it's not good, but I would like to have some sort of that. The current REPL has a banner: hey, if you find a bug, let us know. But I would like to have some sort of detection. And then in general, any ideas that will improve this as a learning environment or for exploration will be really beneficial, I think. Knowing how other similar projects like iHaskell has done will be good. What are the experiences from a compile language using the notebook, and if it's helping or not for learning environments and discovering more the language. So that's the talk. Thank you very much. I think we have a couple of minutes for questions if there are.
A question on YouTube. Will it be possible to run kernel on top of an existing project to require project stuff that takes several minutes to compile? Maybe on some precompiled artifacts?
It is possible, if I get it right, the question, like it is possible to run the kernel in the context of a project and essentially like the crystal path, which determines which files can be loaded, it is taking into account the current directory of where the kernel was started. So you can, yeah, you can use that as a, so if you put the kernel in the current directory of the project, you can just require like .source and your classes, and that will work because the crystal path is has that information.
But it will take the time to type check that that you expect from your project. You cannot say from that. So the question is related to performance of the type checking. It will still be the time that it takes your project to type check.
Regarding the performance, like the REPL, it is lower than using compiled code, but for exploration, for interactive, where you already are like thinking and pausing, like it hasn't been a problem so far when for the programs that I have tested. I'm not sure if I'm answering the question though. The noise is a bit like echoing, so it's hard to understand.
No, don't worry. Don't worry. So the next question is it possible in Jupyter with CrystalKernel to explore current variable states? So something like the login session, right? That you want to say, what's the value of this variable?
What's the value of this variable? Yeah, you can. Yeah, the whole state it's suspended, or it is like it's similar as in the REPL. You assign a variable, and you can do those kind of things. Like you can assign. I don't know how there here a equals 1, and I will evaluate that, and I have a here, and I don't know that's still there, or I don't know. Can I do this? No, I don't know Crystal anymore. It doesn't work on Crystal here. There. Well, we have variables, and yeah, we can do all those kind of things. Like all the state is there.
Okay. All right. Let's thank the speaker. Thank you, Brian.